Hello, my name is Britta Hild. I'm Managing Director of company IS Predict, and we as IS Predict have realized artificial intelligence projects for years. And it's not only in research, but in operation. Our solution runs 24/7 in real time. Today, I would like to give you a short insight how self-learning and explainable artificial intelligence can reduce energy costs and CO2. So first of all, let's have a look. Where is energy required? Well, actually, without energy, almost nothing happens. Of course, what comes in your mind first is about high energy consumption production, like steel companies. But it's also in automotive and manufacturing. It's in process industry, like in cement industry. It's in building. And of course, moving people, moving goods. So without energy, we have a stillstand. And that's what needs to be avoided. That is why we all require energy. But the question is, how can we reduce energy? So why is it, for example, in production that sometimes you need much more energy for the same output? How can you reduce energy costs, but of course, keep your quality of production, your quality output the same? Then there are complex machineries. How can they be steered? How can they be controlled in order to have best energy efficiency? And more companies are also investing in renewable energy, in wind energy, in sun photovoltaic energy. And how can you make best use of that? Much more questions are there. And actually, I would like to answer those questions. Now, this is a huge table, and I don't want to go through each word here, but let's just have a look at the left-hand side, because we differentiate between 4 optimization levels. The first level is energy efficiency analysis. Then how important is it for certain machinery to reduce energy? How feasible is it? Then better planning. Energy prediction, that's level 2, especially in high variation production. Very important, number 3, root cause discovery, to give transparency of why things are happening, sometimes more energy, although the output is the same. And last but not least, complex machinery, multi-machinery control. I don't want to go through each word, you can read it, but let me give you some examples where artificial intelligence has helped. And let's go to some of our clients. So of course, let's start with energy intensive production in steel plants. And here the steel company Dillinger, they required highly accurate predictions for their very dynamic energy consumption. That is where artificial intelligence can really help. Even if production changes, artificial intelligence understands the changes and adapts itself. So it's not just a solution which is good for a couple of months or a year, but it can run for years and adapts itself. Like we humans, we adapt our behavior as well. The same is the artificial intelligence doing. Next example, it's EVO. They produce wooden pellets which you can burn in ovens in industry or at your home. And they wanted to understand with their dryer, with their wood dryer, why do they sometimes require much more energy for the same output? Because they need to dry the wood so that it can go into the mill. And per ton, sometimes the energy consumption was higher and sometimes lower. What are the influencing factors? Of course, first you think it's about humidity, because this wood is stored somewhere in a warehouse or outside. But it is not that simple. There are much more dynamic influencing factors, and that is exactly where artificial intelligence can find data patterns and find the root cause. And if you know the root cause, then you as a human can operate the machinery like a dryer, like a wood dryer, in a better way. Then let's go to cement industry. Here you have a huge machinery, 10 meters or so. It's a cement mill. And the client said it also depends on the human, which means on the person who is operating the machinery, because there are some people, he compared it with driving a car. Some people like to drive cars very fast. Me personally, I don't like driving fast, but the same is true. Different people run machineries in a different way. And maybe some are more risky, others are less risky. And the question is, how can we ensure that we still have the same output in the cement mill, but with less energy costs? And here exactly data analytics finds the, let's say, the experience of people who have a good feeling how to do it, because the experience is given in the data. When they control the machinery, it is recorded and you have the data of their behavior. And that is exactly where artificial intelligence finds data patterns and then can give recommendations for staff which might not be that experienced, younger people who work in that company who have not worked for on cement mills for 10 years. And then they get recommendations how to run this complex machinery in order to have same output, volume, quality, but less energy. Next example is automotive, Opel. They have an energy plant in their headquarters, which means they produce heat and electricity, but they do not always need all heat and electricity. And electricity you can sell at the energy market, at least in Germany you can do so. And of course you should only sell it if it makes sense, if you have a good margin on it, because if you run that turbine, it costs money, you have to pay CO2 certificates and so on. And that is exactly where the analytics predicts how much energy will be required tomorrow at 12:15, and that's heat and electricity. How much will it cost to produce more electricity, and which prices will probably be reached at the energy fair. And then it gives recommendations for the energy trader, how much energy for which product, for which price should be offered at the energy fair. And then at the end of the energy trading, then you know what has been sold. And then it gives recommendations to the machine operators for the turbines and so on, for the energy plant. Next thing, let's go from production to logistics. Things are moving. German Rail, they wanted to understand if they can reduce energy costs with the help of recommendation systems to the train drivers when they need to start, when they can start a train. When you start a train, you have to move a lot of steel. You have to move a lot of weight forward. But when the train is running, you do not need that much power to keep it running. And if you have too many starts of trains, and we talk here about a city which has around 50,000 starts a day means 24 hours, 50,000 starts. And if you have many starts at the same time, a lot of energy is required at the same time. And that really gives problems for the stability of the energy net. And also a financial aspect, if you have energy peaks, that's not a good thing. So here it is about giving recommendations to train drivers when to start a train, and maybe delay it a little bit, but we are only talking of a few seconds, because you cannot say at the main station at rush hour, I move on 5 minutes later. That's not possible. It's in the range of 1 to 10 seconds in order to reduce energy costs. Then production, let's go to renewable energy. Company Haga, they have photovoltaic plants, and they wanted to be as independent as possible from external energy grid with the help of their renewable energy. And what you see here in light green, it's a charging station for an electronical car, for an electronic vehicle, and that is also consumption. So it's not only consumption, the office, the production, but it's also mobility needs other consumption. And what they said, very important, they must not, or the end, artificial intelligence can recommend things, can control energy flows, but it must not have negative effects on the behavior of the people. So the consumer's behavior must not be changed. You cannot say, all right, you have a business meeting, I would like to leave at 7 o'clock in the morning with the company car, but you know, sun is not out there, so let's start your journey at 9 o'clock. That's not possible. So no effects on the behavior of the consumers. That's important. But using renewable energy in the best way to be as independent from energy, external energy as possible. Then let's stay with renewable energy. EnBW, energy supplier. They have a lot of wind parks and photovoltaic parks, and they wanted to also use the energy which normally you cannot feed back into the grid because the balance might be in risk. And that's exactly where you need predictions and simulations as well. Then last but not least, I talked about electricity, about heat, but it's also other resources. So it's about water supply and having less costs for supplying that water. Very important as well. Those were certain examples from client side, and two aspects I would like to point out. Of course, it's data analytics, artificial intelligence, finding complex data patterns, but there are two additional things. One is self-learning, which means like we humans learn with each discussion, we learn, and maybe something we say it's of interest, so we keep it in our mind, or we say it was not of interest. And some of those things which we learn change our behavior so that we behave better next time. And that is exactly where self-learning comes in. And artificial intelligence needs to do the same, because the world is not static. The world does not stop, which means artificial intelligence needs to adapt to changes, to dynamic influencing factors. And the second thing is explainability. Explainability means normally everybody knows deep learning with neural networks. Neural networks are a good thing for sure, but they are black box. They do not let you know actually why things are happening. So for example, at a logistics client, a rail client, it was about a different topic. It was about predictive maintenance. They had 800 data variables from their locomotives, and they wanted to understand not only when will an engine fail, but also why will it fail. And this why, they worked with neural networks in deep learning, and they were not able to understand the why. And that is exactly important, that we as humans also understand why are things happening. Because first of all, it gives better trust into artificial intelligence results. If you say, me as a subject matter expert, yes, I can understand it. It makes sense. That's one reason. But the other reason is as well, if you understand it, then you can take action in order to avoid those circumstances. That is why automatic adaptation via self-learning and root cause discovery to give the influencing factors is very important. And in this way, you really can have scalable solutions, because you have a solution which is still good even if your processes change. And to sum it up, very important, artificial intelligence can save energy costs, can save energy, can discover root cause, but you need to take care that it adapts itself and that it explains why it does things. Well, that was a short insight. If you want to follow us on our social media, looking forward to hearing from you.